Okay, so let's talk a little bit about these location designs and building your point of view, basically. You've got an assignment where you have this basement design that was put together by Omar Dogan, and it's really sharp stuff. There's tiny little inconsistencies, and I know we've talked about that between the two views, but you have this shoebox view of the basement. Then you have this reverse view of the same space rotated all the way around. These kinds of design drawings are really important when you're going to be returning to the same kind of location, when you're going to be showing all kinds of different angles. These are called master designs. So if you were on a production where they were going to be returning to the same location time and time again, you were going to have lots of backgrounds in that same space. You'd want to make sure you design it up quite extensively so that everyone is drawing the same space accurately. As you can see, all the objects and the furniture are defined, and anything that would be in front of us, like this stuff here, is done up with just the footprint, which we've talked about as well in class. You want to be able to structure those elements in perspective and then plot them out in space. So let's talk a little bit about that. Let's go to this view here. Beyond just the shoebox itself, here's what we really want you to be able to visualize or to understand. The fact that there is a series of units that we've built. So there are 4 units across, deep, if you will, 2 units high, 2 units wide here. And here's how that ends up looking. So tracing each of those units down vertically to the floor, carrying the floor logically through with the corner. Here's how it all breaks down. And you can see that a lot of it is built around halves. So the bottom of the shelf is at the half. The fuse box isn't at the half because it's got that little smaller section there, but it would be if you were looking at it from the front. You've also got the floor grid built the same kind of way. So we connect that across, connect each of those in, and they touch as they move. The base of the stairs, it lines up to the halfway point of the entire room, and it carries through like that. So what you want to be able to visualize and understand is really this. You've got the wall planes vertically. You've got the floor plane on the base, okay? Also important, although you don't really see the extent of it here, I'm just going to turn these layers off, is this grid in the front. So there is that other wall where we've got the stairs connecting. So I've got a little yellow plane here just to show you. You've also got that 3-dimensional space. And really that's what this assignment is. It's about visualizing a complete 3-dimensional space as if we're in it and then being able to draw it from multiple angles. For your assignment, you have to do 1 2-point perspective view and 1 1-point perspective view. And at least one of those views has to include the stairwell, because we want you to be able to understand how to build a more complex object like that. Okay, let's go to the reverse view because we've got some more extensive stuff that we talk about with that. So on this one, it's the same kind of breakdown. I've got the complete grid. I'm just going to drop over top, just like this. So same kind of breakdown. You've got the 4 units across, 2 units high, 2 units across, and there's the floor and the walls, okay? Understanding and being able to visualize that space, that rectangle, that rectangular box is really, really important. And here's why. Above and beyond anything else, what we want you to be able to visualize is the volume that these objects and furniture take up. Okay, so I'm going to drop a little bit of a fade over top of the line work, and then we've got this. These are essentially the footprints of the different features. Okay, so we've got the stack of tires, we got the toolbox, you got the pylon and the box under the stairs, the base of the stairs, and where the stairs connect into the wall. You've got the little alcove for the window, the hamper, the sink, the washer and dryer. Each of those have a footprint. That's the volume, the space that they take up within this environment. And so when you're drawing it, you're not just drawing the details. What you're drawing is the solid form of each of those objects, figuring out where they correspond on the floor, then determining their relative height to each other, and then building them. When you look at it this way, when you understand objects and furniture and spaces this way, it becomes a lot easier to draw because you're no longer just worrying about all the little details. What you're thinking about is those core shapes and volumes. Here's what it looks like overhead. And when you look at it this way, you realize how simple it is. It's 4 by 2 grid. You've got a series of rectangular boxes. You have one rotated box for the base of the pylon. You have the circle of the tires, the circle of the hamper. So it's a pair of cylinders. There's a cone for the pylon. And then the rest of it is a series of boxes with a ramp for the stairs. Okay? I'll be sending you this image so that you've got the floor plan to work from. And you'll be able to double check your own version against. Now here's where we get a little bit more complex, but I'm going to go through it step by step so it all makes sense. Starting with something simple. Here's the eye line. On the very first class, this is what we talked about. It's your vantage into the scene. It's the vantage that we are seeing all the objects and the environment, how it all fits together and what it represents. In this particular case, we're going to be building out to show the entire view of a particular person within the space. So back to the overhead plan, essentially what we're going to have is we're going to have a person standing over here somewhere kind of in around this spot. So they're going to be standing near the chair, looking towards the stairs in 2-point perspective. So the first thing we want to do is establish our scale. Bam. So we've got a person looking into, right now, an absolute void. And we've crisscrossed the eye line with their particular eye, just so that that's where it would, we're looking through their eyes, essentially, although we're standing much further back away from them. But we can see sort of what they see, even more than what they can see, honestly. And understanding that. And also that this person is not just a flat piece of paper, that they have volume as well. So what we do is we add that little bit of volume, and I drop in a real quick little 2-point perspective square. I just roughed this in to give myself a sense of scale, and I want to pull those vanishing points out nice and wide. Remember, as we talked about before, the closer your vanishing points are, the shorter your sort of field gets before you get distortion. So we want to have a nice relaxed view. We want this to look nice and comfortable. And so we pull that back. We're going to trace these to a pair of vanishing points. So these 2 lines correspond to the bottom and then trace across. Now, this overhead plan that I had before, we've broken the space into 4 deep and 2 across units. Now, a person is much larger. One of these squares is much larger than a person. So we want to be able to build one of these little basement units as a square in a way that's proportionate. If I think about how big a person might be, sort of think about, they would probably take up, if you stack people shoulder to shoulder in this basement, really tightly packed together, maybe 4 people across in one of these squares, 4 people deep. That would be literally, packed in like sardines, but that you could make that work. So in that same way, what we're going to do is we're going to build out a series of 4. Now you can do this with repeating shape theory, or you can just sort of rough it in. These are going to get slightly smaller as they go back. 4 by 4. That's 1 square, okay? And then we're going to take those back to the vanishing point. So now I have 1 basement unit. If we want to call it a boonit, we can call it a boonit. But we've got 1 square out of our 8 that we need for our floor plan. Well, how do I get the rest of these squares? We've already gone over this in class. Once you have that first square, all you have to do is use repeating shape theory. So I'm going to take that first one, I'm going to find the middle, then carry through that center. Where it touches on the next line is where my next unit starts. Then I do it again across on the next one, and I'll get the next in there. Here's what it ends up looking like. So now I have 1, 2, 3. Only 3, even though it's a 4-unit room, because remember, my character is standing here. So because of that, the 3 are, he's already in the 3rd unit. So we're going to ignore the dryer, the washer, and the sink because that's all behind him. All right, moving right along. So we do the same trick the other way. Do the repeating unit trick there. And now we've got our breakdown. So what we have now is 6 floor units already figured out. Great, this is a really good start. But what we need to figure out now is the vertical height of the room in this back corner. And as soon as we figure that out, we can take it back to the vanishing point and we'll know the vertical height of the room on all sides. How do we do that? We're going to do that with our scale. So if we go back here to the design, actually I'm going to go to this one, and we imagine that a person is going to be about yay high coming through a door, we know what our relative height is. A person is going to come to just over the halfway point, maybe a little bit taller, maybe a little bit smaller. There's some variability there. As long as we get the overall scale correct, that'll work. But I need to know how tall a person is on that back wall. Again, we've talked about this in class already. Once you have a person in space, if they are on the same ground plane, wherever their feet are, you know that eye line is going to be the same. So, bam. What we've got there is someone is that big on the far side of the room. Their feet are planted on the same ground plane, and their eye line crosses the same part of the anatomy because they're the same height. I mean, it's the same person. I literally took the graphic here and just scaled it smaller. We can find them anywhere in the room because we know that if they're standing on the same ground plane, their eye line is going to cross the eye line, in this case, the literal eye line, although it doesn't always have to. And so here's another example. If someone's standing here, their feet are on the ground, their eyes are crossing at that point. Okay? So it's a really quick and easy way for you to understand scale. Now, based on the height of that person, I can work out the rough height of the room. They are this tall. We give ourselves a little bit more space at the top, and then I'm going to carry that back to the vanishing point. I've got a vertical height for the room. We just carry that forward, connect it to the base, and we've got this entire wall built. Do the same thing to the opposite vanishing point, and now we have this wall built. So very quickly, I have that shoebox view that I'm looking for, okay? If I find the halfway point of this particular wall surface, now I've got the ability to quickly break this into perspective units. And as you can see, I've got my 2x6. We would have 2 more here, but again, that's where the washing machine and the sink are, and we're looking towards the stairs. So I've got a 6-unit floor, I've got my 2-unit high and 2-unit across wall, and then my 6-unit wall. Everything's built and ready to go. So what I'm going to do is I'm going to remove some of the extraneous lines because it's getting a little bit busy here, and I'm going to just show you sort of a perfect grid built, already ready to go, so we can stay focused on that. I'll remove the extra people. Bam. Get rid of some of this stuff as well. There we go. Nice and simple. So now we can stay focused on the construction. So what we have is we have the person standing in the room. We've got our shoebox view ready to go, and we can start laying in the different elements. How do we do that? We use our overhead plan. So based on where our person is set up, we then start plotting all the footprints of all the objects and the volumes. All right, how does that look? Something like this. So we take all those basic shapes, those ellipses, well, circles in perspective, ellipses. We break them down into their basic units, measure and compare them to each other, and here's what we get. Okay, so let's get a little bit closer so we can see this. And now you can see, pull back a little bit there, how that all fits together. So we've got our person for scale, we've got our footprints for our different objects, and we can start sketching out relative heights based on the scale that we've established here. How tall are each of these things to each other? Compare it to the plan. Build up each of those objects in turn, and you'll have yourself a finished proportionate view. So let's go through one of these. I did the little footprint for the pylon on the ground. So let me just remove all this other stuff. Do like a quick little sketch. Now this one is a little bit lopsided because I want to be able to check it. So I roughed in the footprint of the pylon. So we need to be able to find out where the exact vanishing points are for this particular one. How do we do that? Just like this. So this has to go to the eye line. This object is on the same ground plane as everything else. So even though it's a rotated object and it's going to have its own vanishing points, it must go to the same eye line if it's sitting on the same ground plane. It's not a tilted plane, so it gets its own vanishing point, but on the same eye line as everything else. So here's the first vanishing point, but how do I find the second one? Again, we've covered this in class, but I'm just going to show you again here. So what we've got is, we've got our vanishing points right here. There's our original vanishing point for the left and the original vanishing point for the right. So now we have the distance. This distance from the left vanishing point to our new vanishing point for the base of the cone, that gets repeated again. If I've rotated that much, then the other vanishing point has to rotate the exact same amount. So I'm going to pan all the way over, and if we take the exact same distance, track it all the way here, we've got our second vanishing point. It's far out there, but it is accurate. So now we can carry that vanishing point over, and what you'll see is my little sketch version wasn't accurate, but now I can build the base with accuracy. Once I have those corners properly built, I'll get rid of my original sort of loose sketch. Now I've got that base properly rotated. Now I can build up my vertical lines, trace those to the same vanishing points. I'll get rid of all the extraneous stuff here, and what we're left with is a proper constructed box to the proper vanishing points. From there, I'm going to find the center of each of those spots, just like this. Do an ellipse in the center of the bottom box, and then create a cone that touches into the center of the top box. So that's how you make the pylon. All the shapes, all the different stuff that we built for this particular design is purposefully made to be quite straightforward. They're all based on really simple abstract shapes, nothing really complicated, so that you can get used to constructing more complex things by subdividing, just like we went over in class. Okay, so let's look at a more complex object, probably the most difficult thing in the entire design, which is the stairwell. So I'm going to remove the person just so we can focus fully on the stairs, how it works, how it's built. So first thing we need to know is what space the stairs take up. So if we look at the original design, what we can see here is that the square base, it's a rectangle. So it's 2 units deep for the entire stairwell, and it's 2 units high, but it's only 1 across. So we want to get that initial volume. It also has an entryway for the top of the ramp, and it's got a base for the bottom of the ramp. And those are 2 rectangles. So they're pretty easy to visualize. So all we need to do is we need to figure out that box. So we take these back to the vanishing point on either side, and we build that box. Pretty straightforward stuff. Really, really basic. The floor units, the height. That's the volume that the stairs will take up when we're finished. Now what we need to do is figure out those two footprints. One for the base, one for the top where it connects into the ramp. So we accurately plot those based on our units, and then we just connect the two of them. Bam, just like that. So you've got the ramp. Now we have the ramp of the stairs, but what we don't have is we don't have the individual steps. And that's really obviously quite important. We know where the stairs will fit eventually, but we don't have each individual stair worked out. So let's break that down. Just going to remove the extra stuff. So the first thing we need to know is what the relative heights of these are. Oh, I'll get that box back. So if we look at the entire height of the stairs and we break it down, this was actually broken into equal sections. So you'll see there are actually 1, 2, 3, 4, 5, 6, 7 stairs. And the way we break that down is there's a middle and then there's 3. So if you break the entire box in half, you'll get 1. Break it in half again, and then break each of those in half. So you can do that with subdivisions, or quite honestly, the easiest way to do it, because this is a vertical line and these aren't going away from us in perspective, you could literally just measure from the top to the bottom and then break it into 1, 2, 3, 4, 5, 6, 7, 8 equal sections. So you can break that into 8 equal sections and you'll have your proper measurements. Once you've done that, you then need to trace it back. So how you do that is relatively straightforward. You have all these subdivisions in the box. We're just going to take those back to the vanishing point. Just like this. Whole lot of lines going on. Each one of these stairs goes across. You're like, well, that's great. That is the positioning. They're equally positioned in perspective, but where will they show up on the stairs? Actually, that's really straightforward. Now that we have those lines in space, all you have to do is drop them into the ramp. So where they correspond on the ramp is where they will show up as a stair. Once you've got one side plotted, and you could do this on the far side of the stairs or the close side, it really doesn't matter. As long as you're accurate about it, you can then trace each stair back the opposite way. What does that look like? Well, it's a whole mess of lines, so this is going to get pretty crazy looking. But believe it or not, this is what it looks like. Bam. Just like that. So now you've got each individual stair all broken down. I know that looks really messy, but that is all the line work that would carry across over to the vanishing point. Now this looks like total chaos. So what I would recommend you do is when you're building this, do the stairs in particular on a separate sheet of paper on your light table. Make sure you're accurate, work with different colors, build this thing carefully, and then go back over it and just pick out the lines that you need. So this is what that looks like. If this is sort of the white of the paper, I'm just going to move this down. If this is the white of the paper, and here's that initial box, this is what the ramp is going to look like. And these are what the stairs are going to look like. Once you trace all those lines, this is what you end up with, okay? And notice, of course, because the eye line is here, as we're getting further away from the eye line, we're seeing more of the top of the stairs. And as we move away from the eye line, we're seeing more of the bottom of the stairs. That's the way the eye line works. Right on that first class, we talked about that. As stuff gets away from the eye line, we're seeing more of it, and everything compresses into the middle. So we've got a nice, accurate set of stairs, plotted and built in space. Okay? All right. So from here, you can take this same idea, all the stuff that I've been talking about, go through with all the individual little footprints, build out each of those sections, and build up all the detail. What does that look like? Let me show you. I'll just put this in the center. Here's sort of a breakdown. So you can get all the different objects in place. I roughed out some of them based on their positioning, roughed out their overall forms, and I'm constantly checking it against the original design. So I'm looking at the original design drawing, double checking all those little details, proportionate elements to each other, going back to my drawing, making sure those are the same. Are they the same width? Do they feel like they're the same object? Double check the height, double check the width, double check the little details. This is still quite sketchy in spots, but overall, we're making good progress on it. This is something that is detailed enough that you could then set up for your final view. What does that final view look like? Well, let me show you. Remember, we're not just doing the shoebox view. What we want to do for our final is we want to show what this looks like from a particular person's point of view. Whose point of view? This guy right here. So we're looking through their eyes into the scene. So we're not going to see their feet. We're not going to see the stuff even near their feet. What you want to do is you want to have a nice kind of relaxed rectangular view. Here's an example of one that breaks down exactly what they're seeing. Once I've got that, I can shift it a little bit. So maybe the composition works a little bit better this way, or maybe the composition looks a little bit better that way. You've got some flexibility. Remember, that character is not going to be in the final, so I will drop them out. This is what the final drawing is going to look like. So I want to compose the view in a way that's going to make sense, that's going to look good. It's a good thing that I drew that toolbox in the bottom because it's going to show up just in that bottom corner there. And then I compose my scene the way I want. Zoom in on this particular view, or in your case, your drawing itself. And essentially, this is what I'm going to be using for my for my construction drawing. So now what I can do is I've got this built. I can print this out, or in the case of your drawings, you can photocopy it up to size, and then you're going to clean up this particular view. So I've got my 2-point perspective view of the scene built from the character's point of view, proportionate with all the different elements in place. And the way that I do that is by building the room grid first, figuring out what angle it's going to be from, making sure all those elements are proportionate, and then building up each of those objects from the footprint. Now, this is a really arduous way to build a room. It's actually a lot more steps than you would use in production. So when I'm going around to do layouts, I don't sketch out crazy shoebox views and rotated grids very often. This would only be used for very, very exacting kind of design work where you need to get absolute consistency from view to view. If you were going to use a space this much and be this hyper accurate, nowadays, honestly, you'd probably do it in 3D. But for the sake of the drawing skills involved, and for the type of technique and consistency to understand how to work from a design and to be able to reproduce it, I think it's a really valuable assignment. I think it gives you an understanding of all the theories and the stuff that we've been covering. We've talked about, those different elements, building three-dimensional objects, building them with volume, figuring out what your point of view is and understanding what your scale is. Once you have those elements in place, you can draw pretty much any environment you want. Once you know what your scale is, once you know the size of your space and our point of view on it, you have tons of flexibility to be able to move throughout a space, to be able to draw accurately, and to be able to understand, the volume that you're putting on the page. So it seems pretty daunting at first, but it's really just extrapolated from the theories that we've already covered. You already know how to make volumes, you know how to do repeating shapes, you know and understand how to rotate boxes, you know how to build ellipses, and that's all this is. It's a series of basic steps all kind of coming together. So don't feel, too intimidated by it. If you are careful and you're methodical about it, if you take care particularly in the initial building stage, when you're putting together that grid, if you take care and look at the design at each step to make sure you're not rushing through things or trying to get right to the detail, you'll be able to very easily and accurately reproduce that design from whatever angle you want. So you need to have one point perspective view, and one 2-point perspective view. And I'd recommend that you have them sort of looking opposite directions. So one of your views should be looking towards the washing machine and the dryer, and the other view looking towards the stairwell, the stack of tires, all that kind of stuff. So we get a real sense of this space in its entirety and then build it out. Hopefully you found this really helpful and in a way that you can go back, rewind, rewatch, look at each step and understand it. Otherwise, keep plugging away and I look forward to seeing your progress.